Good morning, physics students. While you were out, we were talking about the size and the scale of the solar system. So the solar system is very hard to comprehend how big it is. So we like to build a scaled down version model, kind of like building a model car, a teeny tiny model car, and using that to picture how big the car actually is. So what I'm going to do is I'm going to say pretend the Earth were the size of a basketball. Okay, so you know what a basketball looks like. You know how big a basketball is. So pretend the Earth is the size of a basketball. Well then, if the Earth were the size of the basketball, how big would the moon be? So question 1 asks you this. So what I'd like you to do right now is go ahead and make a prediction of how big you think the moon would be. So for instance, pick a different ball. Is it the size of a golf ball? Is it the size of a tennis ball? Is it the size of a softball? Is it the size of a lacrosse ball? Anything you want that you can figure out that it will be about the size of. Go ahead and fill in your prediction. Then what I'd like you to do is pause this video and read the next 4 questions as well, and go ahead and put in your prediction for those questions as well. So how big is the sun? Where will the moon be? Where would the sun be? And where would that nearest star be? So go ahead right now and put in your prediction. Now that you've got your prediction, let's go ahead and let's figure out what it will actually look like, and then I'll explain how I came up with those answers, okay? Turns out that if the Earth were the size of a basketball, the best approximation for the size of the moon would be a tennis ball. Okay, so picture how big a tennis ball is. This next question asks, where would we put the moon? Where would we put that tennis ball? So for instance, let's say I have the basketball sitting on my front desk here in the classroom. I would have to put the tennis ball, and most people think, oh, maybe it's an inch or 2 above the basketball. It's not even close to that. I would have to put the tennis ball all the way in the back of my classroom, about 24 feet away, for that basketball and the tennis ball to be to scale their appropriate distance. That's a huge distance compared to what most people think, okay? This next question is tough as well. How big would the sun be? And if the Earth were the size of a basketball, which is again about 10 inches in diameter, which is less than a foot, the sun would be 87 feet in diameter. That's huge. Okay, that's about the length of our hallway right outside our room, or about, if I took one prospect, three stories tall, and put another prospect on top of it, it would be about that height. Okay, so that's a really, really large ball there. The sun is significantly bigger than the Earth and significantly bigger than the moon. You probably knew that already. Another tough question, where would the sun be? Well, we'd have to put the sun 1.78 miles away from my desk where the basketball is sitting. If you're familiar with the downtown Arlington Heights area, that would be at Peggy Canane's. If you are familiar with the more the Mount Prospect area, that would be all the way to Lions Park or all the way to the Mount Prospect Golf Course. And we're going to talk about how I figured that out as well, okay? This next question is almost too tough to fathom, all right? If the Earth is the size of a basketball, where would I put the next star that's closest to us? It turns out we'd have a tough time doing this, okay? Because you would have to put it at a distance so far away that you'd have to circle the Earth 19 times. That's a big distance. Or alternatively, you could just go the distance to the moon and back. So you'd have to go twice the distance of the moon. Not our little fake moon in the back that looks like a tennis ball, but to the actual moon in order to build a properly scaled model where the basketball was in the front of the class on my desk, and then our nearest star would be as far away to the moon. So that's kind of crazy when you think about it, right? So you might be wondering how I figured out all that math. I know you're very excited. So go ahead and get your calculator out right now. Pause this and get your calculator out, because I'm going to explain how to build a scale model like this, okay? So let's take a look at some information here. We know the radius of a basketball, and we know the radius of Earth. So we're going to go ahead and we're going to determine a proportion, right? The radius of the basketball is this in miles, and the radius of the Earth is 3,959 miles. So what I would like you to do is I would like you to plug these into your calculator. I want you to put in 7.536 times 10 to the negative fifth and divide that by 3,959 miles. Go ahead and do that now. Go ahead and hit pause. You should have gotten about 1.9 times 10 to the negative eighth. Go ahead and store that in your calculator because we're going to use that number a lot. The way you're going to store that is you're going to hit the STO, S-T-O button that's right above the on button for most of your calculators. And then you're going to hit the alpha button. That's directly below the second button on most of your calculators. And then you're going to hit the A button, which is the same as the math button, which is the button right below the alpha button. So once you do that and you hit enter, that number is stored in the letter A. So anytime you want to access it, you just hit alpha math again and hit enter, and poof, there is your 1.98 times 10 to the eighth number. Okay, so pretty simple. Now, the way I'm going to use this to figure out where things will go in my model is I'm going to take that number and multiply it by the actual distance in real life. So for example, when I multiply that 1.9 times 10 to the negative 8 number by 9.32 times 10 to the 7th, I get 1.77 miles. Okay? And now I have to figure out where that's going to look on my map. So let's hang on just a second and we'll take a look at that. Alright, if you have not downloaded Google Maps, you should go ahead and do that. And then these instructions here do a nice job of explaining how to move the map around and look at that on Google Maps. So you can go ahead and do that. I don't think I can show you this on the little app I have here for creating that movie, but some of your classmates will be able to help you once you get to class on Friday. Okay? So that's it. Go ahead and finish up this document. Put in all the actual distances, put a location on the map. If you have problems in class, your classmates will be able to help you on Friday. Take care.